Welcome, all, to the biggest questions in the universe. This is the fifth such public science panel, which has been brought to you by the University of Washington's astrobiology program. Thanks for joining us live on YouTube, where you can follow the UW Astrobiology channel. It's full of lectures and videos all about astrobiology, including our previous public science panels about the best place to look for life in the universe, how we'll recognize life when we see it, and more. My name's Evan Davis. I'm a research scientist in the UW Astrobio program, and I'm joined tonight by four of my fellow scientists who are all driven by their curiosity and passion for what lies beyond our pale blue dot. Since the first humans gazed up at the glittering night sky, we've maintained a strong curiosity for and connection to space. Now, many thousands of years later, we find ourselves at a precipice. As we extend ourselves into this endless expanse for the first time, we ask, what is our future in space? Tonight, we will meet four astrobiologists who all find this question particularly important. Our panelists will share their thoughts and insights in a moderated discussion, which will last about 40 minutes. In the final 20 minutes of the panel, they will answer your questions, which you can type into the chat box on YouTube. Before we begin, though, we want to note that the questions asked tonight will be more philosophically and ethically based than those of previous panels, and that the views expressed here are those of the individual panelists, not necessarily the University of Washington or the UW Astrobiology program. I'll also advise you that there will be a friendly audience competition of sorts towards the end of the panel. I'll reveal more about that later on. With all that being said, let's get to know our panelists. Panelists, in 2 minutes, please say a few words about who you are, what you study, and where your favorite place on Earth is. Greta, could you start us off?
Sure. My name is Greta Shum. I'm in graduate school studying atmospheric sciences. Before coming to grad school, I went to college and studied literature. So specifically, I was intrigued by utopian literature, which is often it's structured with having a main character that's struggling, exploring a utopia as a place that's distinct from where they live or where we live now. And the whole point of building this utopian world is in order to say something interesting about the world we live in today, and in a related way about humanity. So in my undergraduate research, I explored how the search for life on other planets is analogous to this device. We can be intrigued by life in outer space or on other planets, and that can be a way of exploring ourselves. So this leads me into what I study now. In graduate school, I'm exploring how plants affect the atmosphere and how that altered atmosphere that's been affected by plants can feed back on the climate that's affecting those plants. So in order to do that, I use computer models to simulate imaginary landscapes or landscapes that are from deep in Earth's past in order to understand some fundamental aspects of our climate system. And then you asked, what's my favorite place on Earth? I would say it's probably a little neighborhood called Brookside in Kansas City, which is where I grew up and where I still think of as home.
Awesome. Thank you, Greta. I had no idea that you studied literature. That's such a cool dichotomy out there. Hector, would you mind going next?
Sure. So yeah, my name is Hector Delgado Diaz. I am a rising third year student in the astronomy department in University of Washington. And before I started studying astronomy, my bachelor's was in general science because I'm someone kind of undecisive I was somewhat kind of undecisive of what I wanted to study. So I didn't know if I wanted to study biology, chemistry, or physics. And it was until almost like when I was in senior year of my undergrad that I was like, oh, wow, I like astronomy. It encompasses the three things, biology, chemistry, and physics. So I decided to study that for the future. So I had to do a master's in physics because I didn't take any astronomy courses, only one intro to astronomy in my undergrad. So that wasn't enough to continue for astronomy. So I did a master's in physics at California State University in Los Angeles. And then I started my astronomy and astrobiology journey at University of Washington, where right now I'm doing modeling of the James Webb Space Telescope and how this instrument will help us understand exoplanets or planets outside of our solar system. And how can we, based on the observations from the telescope, how can we assess if there's life by looking at their atmospheres? And because the telescope still hasn't launched, me and the team, we do like simulations of what would the telescope observe. And there's like endless possibilities because we don't know how these planets are, like what are they composed, what could they have in the atmosphere, whether they have life or not. So we're just making a lot of simulations to see, once the telescope launches, to compare our simulations to like real life data. And the question about what's my favorite place on Earth, I might be biased, but I would say Puerto Rico, where I grew up. And yeah, it's a paradise basically, and more of a paradise. There's also opportunities to study, just so you know, because people sometimes see it's just like a island of like a just adventure, but there's more to it. So yeah, that's my favorite place of Earth.
Awesome. Thank you, Hector. I definitely understand what you're saying about astrobio being such a great place to be able to, come into contact with all these cool scientific fields. Theo, would you mind going next?
Yeah, sure. So my name's Theo Weiss, and I'm a doctoral student in the Department of Psychology at the University of Washington. I completed my bachelor's at the University of Southern California, and I studied neuroscience and English literature. So cool to hear that, Greta. And so for my research at the University of Washington, I work in a lab called the Human Interaction with Nature and Technological Systems, or HINTS lab for short. And I completed my master's thesis looking at the importance of interacting with nature for children, specifically preschoolers at a forest preschool that takes place school year round outdoors in a part of the UW Arboretum. And then now for my dissertation work, I'm looking at so we know nature's important psychologically and physiologically, not just for children, for people. And how could we get this to people in a way that is not in a technologically mediated fashion? So using, if you don't have access to nature or you don't have the ability to go outside, can we get this in another way? So for me, I'm looking at simulated nature in virtual reality. And favorite place on Earth, I'd have to say, I grew up in the Mojave Desert of California. Joshua Tree National Park is probably my favorite place on Earth. It's really cool.
Thank you, Thea. I've never personally been to Joshua Tree, but I've heard fantastic things, and it's definitely on my bucket list. Dominic, could you go next?
Hi, everyone. I'm a PhD student in psychology, like Thea. I study the distributed intelligence of the octopus. Specifically, I investigate the role that the octopus's arms and suckers play in their perceptions, their decision-making, and their cognition. Our common ancestor with the octopus was a simple worm that existed over around 500 million years ago. We have since evolved toward intelligence independently. The octopus therefore serves as a great model for how intelligence might evolve on worlds beyond our own. So that's what brings me here with you all. And my favorite place on Earth is probably Mount Rainier in Washington State.
Fantastic choice, Dominic. I also did not know that our common ancestor with octopi was a worm. That's a really cool little fun fact. And thank you all. We're happy to have each of you on board this panel tonight. So our first voyages into the inky depths of space began only a handful of decades ago, a mere blink of an eye in the scope of human history. As we venture further, we're discovering that extended space travel can have unexpected consequences for our minds and our bodies. Thea, could you illuminate us on how humans react to space travel and the kinds of technologies that may be needed or are in development right now to mitigate those effects?
Yeah, sure. So with respect to humans in space, what we know about the complications that exist for people in terms of both psychological factors and physiological factors comes from time spent on the International Space Station, as well as other shorter duration missions that have not gone beyond low Earth orbit except for the moon. So when we're thinking about the future and venturing to longer distance and longer duration flights, especially with Mars on the potentially distant but not so distant horizon, we're really looking at what we know from these low Earth orbit missions. And so for NASA, they categorize the psychological and physiological complications or issues into 5 different categories. So we have radiation, isolation and confinement, distance from Earth, alterations in gravity, and hostile or closed environments. So underneath, nested within each of those categories are many, many issues, but let's start with radiation and just think about what's the biggest problem there. That radiation might be considered one of the largest and most pressing threats to human health, especially if we're thinking for longer duration and going to Mars. There's exposure to galactic cosmic rays, and just it's exposure to radiation that we simply cannot replicate on Earth. And isolation and confinement is not only a physiological problem in not having a whole lot of space the further you go out, but also psychologically on the individual level and also at the team level. Distance from Earth, if we're going to Mars, it's 140 million miles away. And we're gonna have, as the Earth, recedes into the background, there's gonna be communication delays. There's gonna be no way to turn back if anyone gets sick or if there's something that's needed or something goes wrong. So the greater distance from Earth is a problem just logistically, but also psychologically. It's gonna be difficult. If anything happens on Earth with your family, there's really nothing, there was never anything you could do about it at the ISS, but there's even less you can do, and it's going to be a longer time before you're able to come back. Gravity or the lack thereof is a huge issue, both in terms of any kind of the duration of the trip, say from here to Mars, but also once you're on Mars, it's 3/8 of the gravity that's felt on Earth. And then just the hostile closed environment, that you're in a really small space and it's going to be hostile, and there's going to need to be a way that people can divide their time or make a sense of privacy from other people. And that's where some of the research I'm looking at in terms of virtual reality, augmented reality, that can provide a means of mixing up the space with respect to augmented reality, as well as virtual reality, and creating a new space.
Very interesting. Thank you, Thea. I didn't realize there were that many, different types of ways that space travel affected humans. In that vein, the effects we're learning about in our spacefaring infancy are likely just the beginning. If humans ever achieve interstellar space travel, the distances we would have to cross would be unlike anything we can fathom right now. To our other panelists, do any of you have thoughts on the limits of human space travel? Will we ever visit another star system? And if so, how might we get there in one piece?
I would say that, will we ever visit? I hope so, right? As of now, currently, our technology, it's limited by what we can do, and traveling to the nearest star, it would take years if we travel by the speed of light. So we need to pass that hurdle first of how can we get there in a good amount of time that people would still be alive by the time they get there. And yeah, I kind of like that movie, kind of good movie, Passengers by Jennifer Lawrence and I forgot his name. The one that they're cryo-sleep in pods, and then they take 99 years to travel to another star. So for example, they put that, either do we want speed to get to the star, or do we or if we get slow, how can we preserve the human? So they pose that question of speed versus preserving the life. And that could be, I don't know if cryosleep is something, a possibility, but maybe like a sci-fi type of thing. Like, I hope things like that could be invented in the future.
Thank you, Hector. Does anyone else have any input at all?
Yeah, I think one of the most difficult things that we're going to run into when discussing or looking forward to space colonization is going to be, and I'm echoing some of what Thea said here, self-sufficiency is the ability to sever ties from Earth. I think we can get humans to the moon or Mars and they can probably stay there, and they might even be able to stay there for a number of generations. But what about being completely separated from Earth's resources, right? Being on our own and being independent of Earth's help and resources will be like an incredible engineering challenge. Where will we get air? Where will we get water? Where will we get food? What about power? And so this problem is going to be like compounded when we won't have a chance to turn back, when we're like dead set on the TRAPPIST system or another habitable world possibly, and there's just no going back. What if we run into problems?
Yeah, that's a very good point. Thank you, Dominic. Well, regardless of whether or not we ever reach other stars, there are still plenty of planets and moons in our own solar system. From the dusty red plains of Mars to the icy crusts of moons like Europa and Enceladus, there are whole worlds we may soon step foot on. However, we must not only ask whether or not we could, but whether or not we should. Hector, could you share with us some potential consequences of humans exploring or settling these worlds, and any solutions we're working on to combat those?
Sure. I think so. On the consequences, I think one, starting with like the simple one, would be like, a consequence would be that we start drifting away from Earth. So we start like, this is more on like on the imaginative, like, what people think about moving outside of Earth. So moving outside of Earth would help us like leave that dream of that many people had of like, kind of like Star Trek worlds or Star Wars, Futurama, I don't know, you name it, that we're starting to develop some interplanetary, interstellar, or even intergalactic relation with the universe. But that's on the simple consequence. Now on a deeper level, like us humans, for example, we carry other bacteria with us, and for example, when we send rovers or landers to Mars, NASA, for example, does a lot of like cleaning and trying to like decontaminate all of the instruments that go there, because when we go to another planet, we don't know how, for example, organisms that live on Earth could survive in the planets that we go on, that could disrupt the life over there. And let's say, for example, we go to a moon or a planet that we haven't explored that much, and we don't know if there's life or not. Even if us humans, like, let's say, try to like go to places that we have gone to, that for example, on Mars, there's places that they've seen that maybe there's no life on that region. Even if we, let's say, we spot ourselves there, we have seen that on Earth, humans have affected climate around the whole globe. And even in places that we're not there, we can also affect the environment and we can disrupt it. Kind of like in the poles where there's no, for example, there's not like humans in, for example, like in US, that there's many people, compared to like on the South Pole where there's like a small amount of people, but even still we're affecting the environment over there. So maybe we could do that in other planets that we haven't fully understand if there's life on them, and we can disrupt it. And that's something that we should think about, that do we want to disrupt life? Do we want to, even if we don't know if it's there, and if we disrupt it, will we be living our dream of like interplanetary or interstellar or intergalactic relationship with other life forms? And yeah, there's many consequences that we need to think through before starting to create like human missions to other places.
Thank you, Hector. I think you raised multiple good points. There are a lot of things that we need to be aware of when we start looking into exploring these other spaces. I want to rewind a bit though towards potentially having life on these planets, like you mentioned. Now, the ultimate goal of astrobiology is to determine whether or not life exists elsewhere in our universe. But could that life be intelligent? Can we even quantify intelligence? Dominic, could you explain to us what it means to be intelligent?
Yeah. So I would say it comes down to one's capacity to use information. If I really wanted to break down what I think intelligence is. So for instance, you might ask like how one might acquire and integrate the varieties of information one might encounter in their environment, how they might store this information, perhaps in large quantities, or in different forms. We might store our information both in our neurons, but also in our technology or in writing, for instance. How this being or this agent might extrapolate from this information over time and space, right? How we like draw conclusions about, or how we can look to patterns of the past to draw conclusions for the future and how we might plan for the future. But all these things, like this happens at all scales of life, not just in animals. So plants, fungi, microbes, for example, can all use information from their environment in remarkable ways to generate adaptive behavior. When we assess intelligence of other life forms, we reflexively look for characteristics that we recognize as intelligent, which are commonly characteristics that make us intelligent. This might be sociality, dexterity, tool use, the ability to understand cause and effect and plan for the future. Intelligence is not a hierarchy, though. There are many different strategies for acquiring and transforming information into adaptive behavior. The kind of intelligence we find elsewhere in the universe might look and behave nothing like us.
Very interesting. Okay, so then that begs the questions, what other kinds of intelligence could we potentially encounter on these other worlds? And how might we communicate with them?
Yeah, so if we make if we've already communicated with them, like if we get a signal, chances are they're going to be technological and likely capable of engineering tools of radio astronomy, because we're likely going to receive if we receive a signal, it's probably going to be a radio signal. How else would we have received that signal? So just from that communication, even if we don't understand it, there's a lot that we probably already know about that civilization, because like we know that they're using radio technology. So maybe they're dexterous, maybe they're social, right? There's definitely a lot of things that we can extrapolate just from that one fact alone. If we encounter them firsthand, if we land on a planet and discover this alien intelligence, pretty much anything goes at that point, right? It could very likely resemble an insect or a fungus or a slime mold. And yeah, that's where the fun begins, right? When it comes to communicating with them, I would say technology will be a very, very powerful tool. It can serve as a Rosetta Stone, if you will. Imagine an AI that is able to identify the primary modes of perception of this alien life form, just from their behavior, or perhaps the syntax of their communication, and then translate information into a form that could be understood by them, just by using this information. Imagine sophisticated virtual reality that is tailored to their perceptual systems to translate our information or our communication back so that they can understand it. So I'd say that technology and where technology is going between AI, between like extended reality, virtual reality, augmented reality, will serve as a really promising way for us to mediate the conversation, regardless of what this creature, this being, this intelligence is going to look like.
Interesting. Thank you, Dominic. This all this talk of the different kinds of intelligence that we might encounter has me thinking. I guess I want to pose this question to the rest of our panelists. Would you say that intelligence is an inevitable outcome of biological evolution, or was it more of a historical accident on Earth?
Yeah, this is an interesting question that I have been rolling around in my brain. Is like maybe the counterfactual to this is like if we had the capacity to like audit all planets everywhere and we realized that actually the tendency is for there to be more basic non-intelligent forms of life, what would that mean to us? Would it mean that like actually we are an anomaly? What does that say about our place in the universe? And if all things tend toward intelligence, like it's a little bit less interesting than a little bit more linear. And then if like we found forms of life that aren't as developed, and why like is that the case? So I always imagine it kind of as a comparison to looking for pale blue dots in the universe as less interesting than finding something that's completely different from what we know so well. So I feel like we could think of life, an intelligent life on Earth, as interesting in both ways. Um, yeah.
Thank you, Greta. I think that's a
Without knowing
great
the
point.
answer. Yeah.
Yeah, I think that's a great point that whether or not we discover life that is intelligent or not intelligent, it's going to be an absolutely defining moment in human history. But this also raises the question, what do we do in the moment after we discover life? Do we decide to respect this organism's sovereignty? Do we choose to study it and gain a greater understanding of our universe? Do we make an entirely different decision? Panelists, should we discover life, what do you think our next step should be?
At least I think that I think we do need to respect the organism's sovereignty, because yeah, disrespecting it would mean like would be potentially eradicating it. So because as I mentioned before, like uh, we are like, if we go to another place, for example, we're like an anomaly to them. Like they're not an anomaly to us because we're the ones that are out of place there. So we could disrupt their system and everything. So if we first of all, if we want to study them, we need to respect the sovereignty. And second, I also think that we also have to think of maybe there's other entirely different decisions that we can take. Maybe because we usually see, this is a whole topic, but we usually see space exploration as space colonization, and that's something that I think we need to drift away from it, because as seen in the history of Earth, space colonization itself has disrupted past or passing inhabitants, indigenous people, and do we want to continue perpetuating that thought into our space exploration, or do we want to like create a space, or I don't want to use space, but I'm using the word space for space exploration, but do we want to create a environment where we can have interconnected relations with this life form, albeit intelligent or not? So yeah, it's a deep question.
Regardless of what like we have to gain from this alien life form, we have a lot that they can gain in terms of we have a whole like civilization's worth of information that we could possibly share with them should they ever evolve to be civilized themselves. So some, hypothetical situation might be we find that there are, simple multicellular life forms on a planet that are evolving, becoming more complex. And say we just leave an orbiter there with all the information that we knew that were the most important discoveries from our existence and our civilization, just so they don't have to deal with it, right? They have, they maybe if they had, as multicellular life, they might have to deal with cancer. Maybe we discover some cure for cancer and we just like leave it with them because they might need it at one point. Maybe we include the specs for a nuclear reactor and maybe a warning for a nuclear weapon. something like that. We don't. I think I see it as an opportunity to promote the well-being of another potentially like sentient, intelligent life form. Not necessarily as a way for us to like learn and promote our civilization. There's a lot that we have to offer and not get anything out of it, and that might be incredibly altruistic, but we could potentially make the lives of other civilizations in the universe like a lot better than the lives that they're currently on the trajectory for, just based off of the information that we've learned that they don't have to learn the hard way.
Very interesting. Thank you both, Hector and Dominic, for your input. I think there's definitely examples of both beneficial and destructive behavior that we have the choice, right? Well, some of us are looking for life and finding ways to push the boundary of humanity deeper into space. The vast majority of us humans will be back here on Earth, working through our own challenges. In that vein, there's much debate on whether we should be so focused on exploring space when there are many problems here at home to solve. Greta, what sorts of problems do you foresee us facing here on our own planet?
Yeah, that's a great question. If you're in the market for large scale physical challenges that require collaboration and really, clever innovation, I have very good news for you. You don't have to search outside of the Earth to look for them. Yeah, like first of all, we're already seeing, the start of devastating impacts of climate change, including rising sea levels that displace millions of people. Right in Washington, where most of us are, we have a good chance of seeing at least 4 feet of sea level rise by 2050. And that's not even Washington's main risk factor for climate. There are already, though, 20,000 people below the 4-foot line that live in Washington. But compare that to larger risks like extreme heat and drought and wildfire. These are really gnarly impacts that, if you think through the chain of events, more disasters like drought and heat lead to lower crop yield, for example, like food shortages would be a really big problem. Inland and coastal flooding leads to your home getting destroyed. And don't forget that basically across the board, these impacts hit poorer, more marginalized people disproportionately. And that means that they're less able to build in resilience today to prepare for those. So they're not only urgent problems, but they're really complex. And for that reason, they're also really interesting. So I work in a field that most people think about the impacts of the atmosphere on people on the land surface and how the oceans are affected and how that affects folks on the land surface. But I mean, all of these things are really interconnected, from policy to economics and physics and biology. So it's really similar to astrobiology. And they beg questions like, what land management hypothetical organisms could exist that maximize crop yield? And how do we respond to the energy crisis through new technologies? Very similar ideas. And they require resources and people power. But I think it's really useful for us to think about ways for humans to continue exploring, space and looking for life on other planets and solving challenges on Earth that are not mutually exclusive, that like feed back on each other in really positive, reinforcing ways. So I think my hope is to find a good way for both of the advancements in both fields to play off one another. So climate modeling is really relevant for both astrobiological questions and climate change.
Awesome. Thank you for your input, Greta. I definitely agree that climate change is one of the most pressing issues that we face today, but it can also, that pressure could also potentially help us solve some problems. And some might wonder why we spend so much time and energy looking for life out there when life on our own planet is in so much danger. To our other panelists, do you think we can balance our extraterrestrial curiosity with terrestrial stewardship?
I think this is the issue of climate change is a big one, but I do think in general in life, any crisis also offers an opportunity. And this reminds me of a conversation I had with Dominic like a few years ago at this point. So we were talking about octopus foraging strategy, and he talked about exploration and exploitation. And this issue of us exploring space and trying to balance that with the exploitation that we have acted out upon the Earth, I think does provide us this opportunity to work together as not only a nation, but a global unit of sorts, or moving toward that kind of approach in order to both solve or attempt to solve the best we can the issues that we've created that are occurring on Earth with respect to climate change, but also in looking beyond Earth and exploring space, because that isn't a single nation or a single person job. So I don't have the answers to these things, but I do believe it offers this silver lining of unity if we want to keep exploring space and avoid the crisis we've created.
Thank you, Hector. Did anyone else have, or thank you, Thea, I'm so sorry. Did anyone else have any input on that?
Yes. We're experiencing an unprecedented decline in biodiversity. I mean, it's happening around us, right? It's its own extinction. There's a name to it now, the anthropo something scene extinction. So as we speak, there are species that we haven't even discovered yet that are going extinct. And the idea of that's very tragic. Like there's species out there that haven't even been discovered that are going extinct. We'll never even know whether they existed or not. So there's like literally no time like the present. The world will never be as biodiverse now within our lives as like the world will never be as diverse in the future as it is right now within our lifetime. So there's like literally no time like the present. So I would have a hard time pouring too many resources into looking for life elsewhere that we don't even know exists, while life that we know exists dies around us. What possible discoveries are dying with them? But thankfully, life around us does have a lot to offer in regard to the life that we're going to find out there in the universe.
Thank you, Dominic. And thank you, all three of you, for your input on this subject. I think it's a really important one to be considering. Now, as we talk about how we'll interact with space and our own home and the life that we share with in the future, we must also address how we'll interact with each other. Through efforts across the world, astronomy and science in general have become more accessible to all humans. However, there's definitely more work to be done if our future in space is to be an equitable one. Panelists, who are we inviting to the table when it comes to our future in space? Who can we invite?
So I love that question because it's something that I like to think about, and I just want to start, like, I'm not an expert in the subject, right? So about space exploration, but to who can we invite to the table? So for example, one of the groups that we should invite would be, for example, indigenous people, because we've seen that when we talk about settler colonialism, or when we settle colonialism, meaning when the colonialist wants to settle in the place rather than just look for something to gain, they just permanently settle. And that's something that throughout history of Earth, we've seen it happen, and we've seen how it has affected indigenous people. And nowadays, when we talk about this space exploration, we're still not inviting these groups to be part of the conversation, where they can offer us input of how to decolonize our thoughts of how we can explore outside of Earth. How can we visit other places without trying to think of, like, we need to settle, or we need to, like, make our way in that place, regardless of not there's life in there. And for example, that's one of the groups that I think we should invite to the table, but also and this, I didn't think about it. This was, I don't know if she's watching, but Monica Vidaurri, she brought that to me, that also like we need anthropologists and ethicists in these groups, because they can give us more of a background. Anthropologists, for example, can give us a background of how civilizations evolve, and for example, Dominic has talked about it, how on other planets there could be this type of civilization, and we need that understanding on civilizations and how they interact with one another, and how we, for example, in the future, we're going to interact with them if we ever explore other areas. And also ethicists, because they study how things could be done. For example, for space exploration, there's many questions of what is ethical versus what is not, and this involves many like politics. This involves many things that us as scientists we might not know about. And when it comes to space exploration, I think we should strive to do our best to not disrupt, and to, if there's life forms that we can communicate to, not, it's better to create connections rather than disruptive connections that maybe in the future would affect us. So yeah, we need to think about who we invite to the table when we talk about space exploration.
Thank you, Hector. I think you raise a really good point, that there's a lot that we can learn as scientists, and we can learn as a species from all of our experiences, whether that be from indigenous peoples or from ethicists and anthropologists. I think that could be a very important thing to include in the discussion. Did anyone else have any input on this?
Yeah, I think it's a really, really important question, especially given what's been happening with the space industry. And I think that it's too important of an issue for there to be so few people at the table as it is. I feel like everyone should have a seat at this table. It's too important to us as a species. It's too important to the history of life and the future of our civilization. So everyone should be involved in this conversation, either directly or through some kind of democratic representation. Recent advancements towards space has not been a collective decision for the benefit of humanity. This is no longer a giant step for humankind, but rather for the profit-driven interests of a wealthy minority. Our journey into space, into the cosmic ocean, has been fueled by profit, not by curiosity. It's tragic. We're rushing into the stars at the whims of billionaires. Do they represent the interests of humanity? Do the hundreds of millions of people living in poverty care about this incredible drain on resources? These are billions of dollars that could be spent solving staggering socioeconomic inequality and improving the lives of like everyone on Earth. So I do think everyone should have a seat at the table, because there's too much at stake at this point. There's too many resources involved, and there's too much at stake for the future of our species and like all of life on Earth.
Thank you, Dominic, for sharing your perspective. Do any of our other panelists have any insight on this? Last call. Well, if not, I want to thank each of you for joining us on this panel tonight and sharing your thoughts, your insights, and your expertise. Each of you worked through large, complex questions during this panel, and we don't have all of the answers right now. Often, when we're faced with tough questions, it can be helpful to seek advice from outside sources. So our interactive portion tonight is asking the question, if you encountered intelligent life elsewhere in the universe, what's the first thing you would ask them? And you can submit your, oops, wrong button. You can submit your questions to the link on the screen right here. So that's tinyurl.com/UWAB question. So, yeah, if you were to encounter life elsewhere in the universe and you were able to ask one question, what would it be? And speaking of questions, we've received several over the course of this panel in the chat box, and those questions are for you panelists. So how about we start with a question from Doug Dunbar. What are your thoughts on the Fermi Paradox and the question, where is everyone?
I was gonna talk about it in one of the questions. I don't remember which one, but yeah, like, because so the thoughts of the Fermi paradox is like, it's kind of like that paradox of like, where are the aliens? Like, for example, if there's like, I mean, you gotta put like an asterisk to this, because it has to be not aliens, but like if there's like an intelligent life form there that can have all the tools to like to create space technology to travel, like maybe like if they could, they would have done it already, for example. And there's like a lot of lack of evidence of like of that happening. And for example, like let's say the sightings of UFOs, like that means that if there was a UFO, that means that there was some civilization who had the technology to travel to Earth. So if they had that technology to come to here, that's a lot of technology, for example. And that means that we would have been able to see the technology they have created, or they could have been already here. We would have interacted with them at this point, or we couldn't, or you never know, we could maybe not be here anymore. That's kind of like that settler colonialism idea. It could happen to us, you know. But yeah, I just think that there could be different alien forms, but maybe they're not looking for moving outside of their planet, or maybe they're like at the same level as us, that we still don't have the technology to travel to other stellar systems. So yeah, I don't know if that answered the question.
Thanks, Hector. I thought that was a good response. I just wanted to add it kind of comes down to the question of like, where is the bottlenecks? Where the question is where the question comes down to like, where are the civilized ones, right? Where are the ones who might be out there trying to communicate with us? And it's very complicated getting through a lot of these steps of like origins of life, and then multicellularity, and then intelligence and civilization, and then the technological advancement to get to radio astronomy. There is nothing about intelligence that evolution wants. I think that that's important to kind of to remind ourselves, is that evolution biology doesn't want complexity. And you know, like I said before, like there are, even if you get to intelligence, there's many different varieties out there. Like we're just one of I might be losing my connection here, so I apologize. We're one of many different varieties of intelligence, right? Like technological intelligence is one of many different kinds of ways of thinking and computing the world around us. And it's expensive. Like intelligence is super, super expensive. Like our brains is the metabolic equivalent of one of our legs during a marathon run. And so that's always kind of tugging in the opposite direction. Like, yes, intelligence is very adaptive, but it's also maladaptive as soon as the environment starts to change, because simplicity is what's more adaptive when it comes to complex, quickly changing environments. Intelligence and complexity, it really only becomes adaptive if we have very stable environments that like last. But if you have an extreme environment relative to what we're living in, like microbes are gonna be overwhelmingly, as they are now, they're gonna be overwhelmingly the common kind of life form.
Interesting. Thank you, Hector and Dominic. Appreciate your input. We have another question from Melanie Scott. Do the panelists have any ideas on how we can get people to care about respecting non-human life on another planet when it's so challenging to do so on Earth? It's a good question. Greta or Thea, do you have any input?
Yeah, I think this is a really intriguing question. And I think the difficulty of like getting people to do things or feel certain ways is just such a challenging, it's such a like multifaceted one. And it something that Dominic, you were mentioning, um, made me think of is that one of the things that we often celebrate, especially just like in our storytelling and in our daily lives, is like overcoming adversity and how wonderful that is, and doing the thing that's hard when we know that things happen often more likely in physics with the path of least resistance. So paving a road for people to do the things more easily is just a much more kind and physically reasonable, logical way to get things done, as opposed to necessarily celebrating success over adversity or obstacles, which obviously an admirable thing, but generally not the easiest thing for anyone to do. Like that's obviously a difficult thing. So bringing celebrating the success of building an environment that cultivates support and allowing that to be celebrated, where doing the right thing is easy, is kind of something that I think would require a paradigm shift in a lot of contexts. But hopefully, I think, it's already happening in the sphere of climate. Like people know already that, when you're moving houses or moving apartments, for example, that's a really good opportunity to switch out all your light bulbs, or to make a change to start composting, or make a lifestyle change that would drastically reduce your carbon footprint. So things that so often the opportunities that are put forward at that time for those specific people in those contexts are more successful. So maybe switching our lens to not thinking about the hardest problem, but trying to think of the easiest solution.
Yeah. Yeah, just to jump off where Greta was, this idea of shifting our lens or of our paradigm of how we exist in the world has to do with some of the research that was done by my advisor in the past, and this idea of shifting from a egocentric or anthropocentric concern to that of biocentric. So concern for only the well-being of the self, to concern for all the expansion of the ego or the self to envelop that which is biocentric beyond the self. And I think to get down from oneself to other people, to other animals, to microbes, that which is furthest or most distinct from ourselves, is going to take work. And I can't tell you exactly how that's going to happen, but I'm saying I think it can. We've seen that this could exist this in children. And I think we can see it in adults and across the globe, but it's going to require a big shift in how we view the world and how we interact with it and what we think is important. And it's going to require something beyond the self, and not only self, but like our species.
Thank you, Theo and Greta. We have another question. This one is from Michelle C. For the panelists, what are your thoughts on UFO sightings by people on Earth? Is it something that should be seriously studied by astrobiologists?
I have a hard time answering this question because I personally find UFO sightings really intriguing, and I watch videos about them all the time. But I actually, and I think that they're one among many really ridiculous phenomena that humans don't understand. Like a lot of things that happen in the weather world are like completely surprising and can be explained sometimes. And sometimes I think that we put UFO sightings as like the poster child for the unexplainable, but like there are lots of very interesting things that happen that aren't necessarily understand. Like what Theo was actually talking about, like this like larger sense of community that we have, which is not necessarily something we can like explain. But love is something similar to UFO sightings that I think we have to take seriously if you're going to actually be a part of the universe in this like positive sense. I personally think UFO sightings are pretty intriguing myself, and I don't necessarily write them off. But I also think it's one among many very interesting unexplained things that lots of people have observed.
Thanks, Greta. Anyone else?
Yeah. I would say that the probability of life to emerge somewhere else in the universe, for that life to evolve multicellularity, for that multicellular life to evolve to just to discover behavior or to evolve behavior, to then evolve to civilization, to technology, to being spacefaring, and then for them to come here of all places in the universe, and for them to go unnoticed, and for them to just go into the backwoods of West Virginia, it just I think it's more parsimonious to say that there's psychological phenomena on the one hand, but there's also just astrochemical and astrophysical phenomena that are beyond our understanding. I would sooner say that there are things that we don't understand about even basic astrochemical phenomena. I would sooner say that than that there is an alien coming here. That just the likelihood it's just more likely that there's something about the universe that we don't understand than that we understand it enough to conclude that there's a civilization coming here and abducting people. We should just be humble about this. There are just things that we don't understand yet. We're in no place to conclude that this is an intelligence and a civilization, a spacefaring civilization of all things, to come here and abduct somebody or to fly nearby. It's just not parsimonious.
Thank you both. And thank you, Michelle, for that question. As you can tell, it's a contentious one in the astrobiology community. We have several other good questions. Maybe we have time for one more. Okay, this one's from Kevin Hobson. What controls should be put on the commercialization of space exploration?
Well, just to jump in quickly, my first thought would be building off of what Dominic said earlier, and about how we should be concerned about the reasons, the motivation behind our exploration of space, and who controls that to some extent, and who's making the decisions. And if privatization and private companies and private billionaires, whatever, start to be the primary impetus behind space exploration, I think we might be losing something really beautiful about human exploration of space.
Thank you for your input, Thea. Well, we just have a couple minutes left. We have a couple more questions, but unfortunately, I don't think we have time to get to them. But let's take a look at some of the responses we got to what question you would ask the first contact with life. What question do you ask this intelligent life form? So let's see if I can. All right. So these are our finalists. So we have "What took you so long?" from the Jedi. "Is a hot dog a sandwich?" from Alan. Alan, you're asking the real questions. "Are you a carbon-based life form?" from Rochelle. I think that's a fantastic question. And it's actually, we talk about potentially other types of life that life forms we may find in some of our previous panels, so definitely go check those out. And also, "What do you do for fun?" from Doug. Doug's just trying to have a good time. So, yeah, okay. Well, let's see here. Oh, I almost forgot. One thing we like to do is to kind of and give audience members a chance to follow all of you on the internet, if that's something you're okay with. So could each of you just real quick give us maybe a Twitter handle or an Instagram handle if you'd like?
I haven't used my Twitter in a while, but yeah, I'm planning to use it again. It's for personal reasons, but my Twitter would be Hec_Emmanuel, which is my middle name. And yeah, Instagram, in the future, I might use it for astronomical purposes. But for now, it's it's mostly about me. So maybe you'll be more interested in the Twitter. So I'll leave you with that.
Yeah, I was trying to just remember my Twitter handle. It's capital T HEA capital WEISS 17. So yeah, I'm in a similar boat to Hector, but you can find me there, and eventually I'll see that you found me, and then we'll have found each other.
Yeah, my Instagram handle, or my Twitter handle. You can also follow me on Instagram, but I don't post much more than my knitting. Is Greta Shum, which is my name. So.
I communicate exclusively through carrier pigeon, but occasionally I do check my email, which can be found on the Astrobiology UW's website, in case anyone has any pressing questions about octopus intelligence.
Awesome. Thank you all for that. Don't forget to also follow the UW Astrobiology channel on Instagram. That's at uw.astrobiology. And also don't forget to follow our YouTube channel here, where we've got all of where this panel will be posted and all of the previous panels will be posted. I also would love to give a shout out to my fellow organizers tonight. So big thank you to Lucas Feither, Trent Thomas, and Mike Wong for their incredible behind the scenes work tonight. This wouldn't have been possible without the three of you. Anyways, I also want to say that all of us in the UW Astrobio program want to thank you, our audience, for joining us in these panels. It's been great fun to organize and host these events, and your viewership and enthusiasm make it all worthwhile. This panel concludes our summer series, but please stay tuned for more as we head into fall. All right, well, I think that about wraps it up. So thank you to our panelists, and thank you to our audience. Hopefully we will see you soon.
Thanks, Evan. Thanks, everyone.
Thanks, Evan.
Thank you.